Good morning, ladies and gentlemen. We are going to do this together now. Miss Moore, mass of 65 kilograms, climbs a 0.66 meters up onto the counter. A, what is her weight? And B, in newtons. And B, how much work did she do? All right, come on over here. This counter, yes. Okay.
You want to use a chair? I think you should use a chair.
Chair? Okay.
You got one right there.
Okay. So here we go. Ready, set,
Swimmers, take your mark. Boom.
done. Okay, so let's go ahead. How much work did I do? Let's go ahead and start by calculating my weight. So this is letter A. So weight is the same thing as the force of gravity, right?
Yes, ma'am.
Mass times gravity. And my mass is 65 kilograms. And the acceleration due to gravity is always this when we are on the lovely planet Earth. And so 65 times negative 9.8, isn't it like 630? Yeah, 637. Negative 637 newtons. Okay, letter A. That's my weight. B, how much work did I do? Work equals force times distance. And remember, my displacement was up, and my force is also up, so I can use this equation.
You're doing work against gravity. Gravity was down, but you were overcoming gravity.
My force was negative 637 newtons.
Okay, but make that a positive
Because why?
because you're pushing your body up.
Right? And as we just talked about.
Yeah.
And my displacement was also up, and my displacement is
0.66 meters.
0.66 meters. Boom, boom. Okay, and in case you didn't catch that, Miss Moore put a negative at first, but remember, we just talked about how Miss Moore is doing, her force is actually going up, right?
Yeah.
Same direction. Okay. So 637 times 0.66, and I get 420. 420 joules. Sweet. So that is how much work that I just did. Let's try something else. So the same Miss Moore is going to climb up again. And again, how much work am I going to do this time? Tell me when to go.
On your mark, get set, go! This is old Miss Moore after she's been teaching for 40 years. Come on, girl, you can do this. Come on. Boom!
Okay.
Wait a minute, look, there's got to be another Miss Moore. Miss Moore, show me a better way to do that reflects your athletic background.
What?
Swimmers, take your mark, get set, ho! Boom!
So the first time we did it, I went fast, and the second time I just did it, we went slow, right?
Click,
So,
click, click.
oh, click, click, click. So which Miss Moore is more powerful?
More.
Which one and why? What do you think? The one where I went up fast, or the one where I went up slow?
Powerful.
Powerful. Okay. Well, first of all, what the heck is power?
I know. What the deuce is power? Whoa!
Oh! I forgot which one was next. Sorry.
Well, what was the same both times?
So what was the same both times? Well, I went the same amount of force and distance, right?
So the work was the same both times.
My work was the same, but
What was different?
How much time?
Yep.
Right? I went way slower the second time. And which one do you think was more powerful, the fast one or the slow one?
I think it was the fast one. That slow
Okay.
one was pathetic.
So there's two things involved here, work and time. Those are involved with power. See if you can come up with the equation.
What is the equation for power? We got three things going on. We got time, we got work, we got power. What's the equation?
Okay.
Add, subtract, multiply, divide. You only have three variables See what you think it should be. Remember, what's the same and what's different.
Okay.
So we had a short amount of time and we had a long amount of time. Which one was more powerful? The short amount of time or the long amount of time?
The short amount of time.
I agree. So what should that equation look like, boys and girls?
Did you get something that looks like this? Power is the rate of doing work. So work over time.
Yep.
And work is a joule times seconds. A joule second is a watt.
So what this shows is the inverse relationship with power and time. If you go up in a small amount of time, you're more powerful. If you go up in a large amount of time, you're less powerful. Sweet.
Okay.
And what the joule per second is called a what?
A watt?
A what? It's a what?
It's a watt.
It's a watt.
Okay. What is your weight in newtons? Do this, but with your weight.
I think they should have that already.
Yeah, it should be in your notes. I've done this like a bajillion times now. 637. Miss Moore, remember that, okay? It should be in your notes. Find it. What was your weight in newtons? How much work did you do when you climbed up on your chair?
Remember that yesterday?
It was I think it was 0.45 meters tall.
You've got that in your notes.
Yeah, look at it. Go find it. Okay, you need that information. Okay. Okay, let's go ahead and take a look at page 231. Number 9. It says a box that weighs 575 newtons is lifted a distance of 20 meters straight up by a cable attached to a motor. The job is done in 10 seconds. What power is developed by the motor in watts and kilowatts? But
We're
it
not
just
going to
wants
do the
watts.
kilowatts.
Yeah, don't worry about kilowatts.
Just do the watts.
Okay. Go ahead and take a stab at that.
Pause that.
Pause it. Try and do it. Should I do it with them?
Yeah, sure. Why not?
Okay.
Here, I'll read it to you.
It's good. It's nice to have an assistant.
My lovely assistant.
The key to my success.
My ancient assistant.
Okay. Go ahead, Mr. Boykin.
Okay, the weight is 575 newtons.
Okay.
And the distance up is 20 meters.
Okay.
And the time is 10 seconds. And we want to know the power. So power is work over time. So that work is force times displacement over time. Oh.
How can I get... Oh, this is the force.
Yep.
Right?
Yeah, because the weight down is equal to the force up while you're pulling it up.
Yeah. And is it a book? I forget. What is it talking about?
A crate. Oh, it's a box.
A box. And the box is being hoisted up
20 meters.
20 meters. Oh, sorry. 10 seconds at the bottom. So how do we know whether or not I should make this positive or negative? Because isn't it only weight negative?
Yeah, but this is the motor is doing work against gravity.
And there it is again. Remember when I did work against gravity as I stood up on the chair? The motor is doing work against gravity, so we make this a positive.
Excellent point.
Okay, so 575 times 20 divided by 10. Oh, that'll be easy. Does 1150. 1150 watts.
That's Newton meters per second, which is a what?
Meter per second. What? Okay. All right. So
And now we have a challenge for you, boys and girls.
this is your task. So you are to find the power you develop climbing the bleachers over out in the football field.
Let's imagine that school was in session and you were here and you were going to go out to the bleachers. You wanted to find out how much power you developed going from the bottom to the top of the bleachers.
So think about this. We're preparing right now. What must you measure in order to do that? To be able to measure the power? What must you know? Make a data table to take with you. Well, for me to take with me. Make a report with data and calculations and results. So we want them to do all 4 of these right now?
Well, what we need to do is, what would you do, what would you measure, and what data would you collect when you're out there? We'll make the report later.
Yeah. So these first 3 right here.
All right?
Okay? All right, that's your homework. ahead and begin.